In this tutorial, we will see how big the heat losses are from an unheated apartment to the neighboring unheated or less heated apartments. We will see how increase this total consumption and total bill from the ideal situation when all neighboring apartments are heating at the same temperature. Have you ever entered in a cold winter day in an unheated apartment surrounded with four heated apartments in a thermal insulated block of apartments? You will be very surprised that the temperature in the unheated apartment is almost similar with the temperature in a heated apartment. How is this possible? Let's see. First, we have a central apartment surrounded by four another apartments. The slabs are for concrete thickness and the walls between them are also for concrete with thickness of 20 centimeters. All the apartments are heated at the same temperature. That it means that the radiators in each apartment will generate enough heat to compensate the exterior airflow. The heat between apartments are zero. Now, let's have the central apartment stopping the heating. And the first thing is the temperature inside him will start to drop until an equilibrium temperature when the exterior air flow is equal with the sum with thermal flow from all the four surrounding apartments. In generally, for our climate zone, which will be explained later, this temperature of unheated is between 17.5 and 18.5 degrees Celsius. The radiators in all four surrounding apartments will increase their thermal flows to compensate those flows to go to the unheated apartment. That will generate a total increase of bill for all those four apartments. But because the flow to the exterior air is depending on the difference of temperature between heated apartment and the exterior air, and because the temperature for unheated is not very different from the temperature for a heated apartment, this flow we can approximate to be the flow with a heated apartment. That it means that the energy necessary to maintain this temperature is the same as the energy necessary to maintain 20 degrees. So an unheated apartment will consume almost the same energy to maintain its temperature as an heated apartment, only that this energy will be taken from all four neighboring apartments. Let's see now the same situation from the facade points of view. We have again a central apartment heated at 20 degrees, surrounded by four another 20 degrees apartments. And the energy losses between apartments is zero because there is no difference of temperature between them. Also, the energy losses to the exterior air of the central apartment is equal with energy for heating energy performance certificate. It's a standard one. The other situation is the situation we speak in front. We have an unheated apartment surrounded by four heated apartments at 20 degrees. The thermal flows for the exterior, the apartments, are almost equal with this one because the difference of temperature between them and the exterior air is almost similar. And from the principle of conservation of energy, energy losses from the surrounding apartment and the central apartment are equal with energy losses to the exterior of a central unheated apartment, which is approximately equal with all those thermal flows for 20 degrees apartments. If you are interested in more about energy performance of building, you can find in the description the site, and also at the end of this tutorial will be a link to another tutorial, especially for energy performance of buildings, auditors, or thermal physician enthusiasts. Now let's see which are the calculations conditions. The apartment block is located at a latitude between 40 and 50 north or south. The apartment block is thermally insulated to the outside. The slabs between the floors are made of concrete and are not insulated. The apartment's lateral walls are made of concrete or bricks and are not insulated. The heated apartments from those calculations are not at the first or at the last level of the apartment block. 20 degrees again is standard internal temperature for apartments. For this temperature are made calculations for energy performance certificates. We'll consider a medium of 18 degrees, medium internal temperature for an unheated apartment with all four neighboring apartments heated at an internal temperature of 20 degrees. Here are some explanation. The energy transfer for four heated apartments to a central unheated apartment or to exterior air is proportional with air of contact. We have also a total air of contact between the central apartment with all four neighboring apartments, which is 2 multiply area of upper lower plate plus 2 multiply area lateral walls, and area of apartment contact is the area of contact with a particular neighboring apartment. If formulas are too complicated, you can skip this paragraph. Total energy lost from all four heated at 20 degrees apartment to the central unheated TU apartments a year is equal with energy necessary to heat a 20 degrees apartment a year, with apartment with all four neighboring apartments heated at the same temperature of 20 degrees. Also, we want to see what is the energy loss between the unheated apartment and specific heated apartment. It depends on the ratio between air apartment of contact with air total contact, and again energy necessary to heat at 20 degrees apartment a year. If lateral walls are made of energy efficient bricks or autoclaved area concrete or are insulated, then for area apartment contact between heated apartment and unheated one will take value 0. Here is an example of apartment. The front face to the outside has 12 meters length. The depth of the apartment 5 meters and the height is 2.5. The back wall faces the hall. We'll consider we have no thermal transfer because we'll consider the wall temperature is equal with apartment temperature. Area lateral right is this equal with the left, and area upper plate is equal with the lower plate. The total area is this one, 145 square meters. Energy lost to an heated apartment, to left, right, to an unheated apartment is the divided the ratio between the area and total area of contact for all four neighboring apartments, and it's approximately 10% of energy necessary for heating one apartment a year at 20 degrees Celsius surrounded by another four heated apartments at 20 degrees Celsius, which is the energy for heating for energy performance certificate. Also, energy lost by an heated apartment to upper or lower to unheated apartment a year, it's 60 divided again 145, which it means approximately 40% of energy necessary for heating one apartment a year at 20 degrees. So this ratio on total area of contact depends on the apartments. In general, they don't differ very much. Let's see now the situation for calcul. So all energy losses are calculated as a percent from the energy for heating the apartment at 20 degrees surrounded by four another apartments at 20 degrees. Again, this is the energy for heating and energy performance certificate. In first case, energy losses to the above unheated apartment is 40%. Energy losses to the below unheated apartment is 40% and total energy losses are 80%. To the left unheated apartment is 10% at this area of contact. Energy losses to the below unheated apartment it's again 40% and total is 50%. In this situation, energy losses to the below to unheated apartment is 40%. If lateral walls are made of energy efficient bricks or autoclaved aerated concrete or are insulated, then for area apart between apartments of contact between heated apartment and unheated one will take value 0. So energy losses to the left will be 0. Energy losses to the below unheated apartment will become 50%. Why 50 and not 40? Because in this time the total area of contact between heated and unheated apartment will be only those two slabs, which and half of them will be 50%. If formulas are too complicated, you can skip the paragraph. The person interested can look on it. So, after all, when we discuss the situation between two the apartments and now the temperature is not between 20 and temperature unheated, it's a temperature T1 and another with T2. The formula is this one. So it's the ratio of area of apartment contact and total contact divided 2. And this is the difference of temperature. And again, as energy necessary to heat at 20 degrees apartment a year with apartments and all four neighboring apartments heating at the same 20 degrees. Again, from this slide, all energy losses are calculated as a percent for the energy for heating the apartment at 20 degrees in the same situation as it was in the front. And let's see now, if we have a central apartment heated at 24 degrees, energy losses to all and the surrounding four apartments has 20 degrees. Energy losses to all four neighboring apartments from the formula in front will be this one. That it means the total losses will be plus 200%. Energy losses to the below apartment will be 80% in this case. That means the below apartment will decrease his consumption and his heat bill with 80%. Again, what an apartment losses, it will become the income of the other apartment, and that will decrease his energy use and also his bill. The second situation, it's a 22 degrees apartment surrounded by four 20 degrees apartments. Energy losses to all four neighboring apartments will be 100%. In this case, energy losses to the below apartment will be 40%. So this apartment will decrease his consumption with 40%. And the most complicated case, in this one where we have a unheated apartment upper and two in left a 20 degrees apartment, below a 21 and in the right 22 degrees. Here are the energy losses to the above, it's 80%. Energy losses to the left is 10%. Energy losses to the below, it's 22 minus 21 divided 2, which is 20%. And energy losses to the right apartment is 0 because it's the same temperature, and at the same temperature between two apartments there is no thermal flow.